Our focus today is on circles and chord properties. So the first thing we need to really understand is all the elements of a circle. So straight away we have a center point. Now, so we know that we've got a center point. The next thing I want us to really be able to focus on is the next element. So the next element is us seeing the diameter. And the diameter goes from one side of the circle through the center to the other side. Okay, so now we've got the diameter, we then need to look at the radius. The radius is our line from the center to one side of our circle. So it's half of the diameter. And the final element that we are going to be looking at is a chord. And a chord doesn't go through our center of a circle. It goes from one side of the X circle to the other. So that is this purple line right here. Now the next thing we need to be thinking about, and that's what I'm going to do in the middle circle, is that we have also sector. Now I'm just going to do it in purple over here to show that let's just say I'm cutting this piece out. So this piece I'm cutting out right here. I'll just finish the line off and I'll color in purple. So we call that a sector, and we call the outside part in yellow another sector. But if I'm thinking about it and putting it into words, we use the terms major sector and minor center. And I'm sure you can understand why, because one is a very small part of the circle and the other one is the biggest part. Likewise, on the outside of the circle, it's the arc. So, of the outside of the purple, which is, I'll do it in red, starting at the purple, going around the circumference, the outside of the circle, all the way to the X of the purple. So we call that the minor arc. Likewise, with the outside area, or with the outside part of the arc, it's the major arc. And that is the same thing that applies with our segments. So we've got a segment here, but again, we've got a major segment, and we have a minor segment. And again, that is all. It all just comes down to that sizing area. Okay, now we are going to look at some of the properties of our circle. So the first thing I'm going to think about is we have our center. Now, from the center, if we want to get a chord is going across from one side to the other. But we are able to see it as a isosceles triangle. And I see that because it is going to have, these two angles are going to be exactly the same. So if it goes here, if it needs to go across straight away, it's going to cross and have both of these angles the same. So that means it is an isosceles triangle. So if I do exactly the same chord on both sides, so if I've got a chord here, and again I've got another isosceles triangle. If I say that these two chords are the same, if they are the same length, it also means that my angle of angle here is the exact same. Now the next thing I want to think about in terms of this is, like I said before, we've got a isosceles triangle. So I'm just going to again draw my chord. We've got a chord from here all the way to here. So like I said, from our circle, we are going to be drawing our radius on both sides. So I know if I go straight down the middle of from the radius, so from the center, it is a perpendicular line, but it also creates two right-angled triangles. Two right-angled triangles. It also shows me that these two are exactly the same length, and the angle that we knew we had here would be split between both of them. So these two angles are exactly the same. The next aspect I want you to focus on is, like we said before, if we have two chords that are the same length, then we are able to do a perpendicular line from the center of the chord and from this center of this chord, and it will tell us straight away where the center is of our circle, just by using our chords. In addition to that, it also helps us understand that if our chords are the same length, then it also tells us that the distance from the chord to the center is also equal. So this is also equal to this part right here.